Good afternoon. Today we will be talking about some of the basics of hydraulic systems with a special focus on the components that go into the making of a hydraulic system. First of all, we need to recognize the fact that hydraulics are a way of life today. Hydraulic systems are almost universally used. Let us look at some of the applications that we commonly see these systems being deployed in. As you all know, in an automobile or a car, the braking system is essentially a hydraulic system. And also in the case of aircraft, you know that the landing gear operates through a hydraulic system. The flaps on the wings are also operated through hydraulic systems. And a very familiar sight in most automobile workshops is an example of the hydraulic jack, which is used to lift the vehicle so that the servicing can be done in the undercarriage of the vehicle. In construction equipment, whether it's an excavator, a wheel loader, a skid steer loader, or a tracked loader, we have extensive usage of hydraulics. Why hydraulic systems? A, because they transmit energy efficiently and easily. The loss of energy through friction is very low, and they almost completely eliminate the need for complicated mechanical linkages like gears and shafts. 5 major components of a hydraulic system: the pump, the tank, the motor, the control valve, and the hydraulic cylinder. And we will have a look at each of these components and also broadly how they all sit together or come together as part of a efficient hydraulic system. Today we'll look at 3 primary components of a hydraulic system: the hydraulic tank, the pump, and the hydraulic motor. The hydraulic tank, the primary purpose of it is act as a reservoir for the hydraulic oil, and they have an inlet and an outlet. Baffle plates are provided to prevent the hot return oil from going directly into the outlet and into the system again. They are equipped with measuring devices such as dipsticks, side gauges, or level plugs, so that at any point in time you are aware of the level of oil within the reservoir. They are provided with openings to change the oil, clean the tank, and also change the filters periodically. A hydraulic pump is a mechanical source of power that converts mechanical energy into hydraulic energy. It is usually connected to a prime mover, example a diesel engine. It may be considered to be the heart of the hydraulic system. There are 3 main types of hydraulic pumps: the gear pump, the piston pump, and the vane pump, and we will briefly look at the design of each of these pumps. First, the gear pump, which is a simple and economical pump, and the way it works is there are intermeshing gears which are squeezing oil between the gears and the outer casing, and the diminishing space that is created creates the positive flow of the hydraulic pump. So simple and economical and rugged design. Let's now look at piston pumps, where you can see the pistons working within these cylinders, and the displacement, positive displacement, is created by the linear movement of the pistons, which are in line parallel with the center line of the axis of the pump. The swash plate here can actually control the amount of displacement by changing the angle of the swash plate. Another design is a radial pistol pump. Essentially, the pistons operate or radiate out from the center of the pump. We will now look at vane pumps, where again you have a housing and a rotor and vanes, and the vane moves in and out of the rotation shaft and pushes out the oil. These have generally higher efficiencies than the gear pumps. Now we're looking at hydraulic motors. These are powered by pressurized hydraulic fluid and transfer rotational kinetic energy to mechanical devices. Again, 3 types of hydraulic motors: piston motors, gear motors, and vane motors, which are kind of exact mirror images in the reverse of hydraulic pumps. Now the output of the motor is the torque that it delivers on the drive shaft, and that is a product of the force and the distance. The torque output is determined by the pressure. This becomes larger as the pressure is higher. The speed of the motor is, however, determined by the volume of incoming oil. The greater the flow rate, the faster the speed. With this, we conclude this section where we looked at 3 different types of components that go into a hydraulic system. In the next session, we will be talking about the other 2 components and how these components sit together or work together as one hydraulic system.